We are now going to solve exercise question number 15 because that is related with calculating electric flux. I am reading the question. Consider a uniform electric field. It's uniform field. E vector equal to 3 into 10 raised to 3 I caret Newton per coulomb. So we are given that there is an electric field in some region and it is 3 into 10 raised to 3 Newton per coulomb I caret. Okay. What is, part A of this question, what is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? Okay, so let me draw the coordinate axes. So X, Y and Z, the usual manner, right? And electric field is in I caret direction, that is, it's in this direction. Also the field is uniform, that's mentioned in the question, right? Okay, so this is what we know. And where is that plane? The plane is parallel to the YZ plane. So YZ plane obviously is this plane that's coming out, right? So let's say here is that plane, okay, right? It's a square. Let me just mention that here, it's a square, right? And its side length is 10 centimeter. Okay. So the question is, what is the flux of this electric field through this plane, right? Which is a square of 10 centimeter side and parallel to the YZ plane. So now, as I mentioned earlier, it's just that this is a flat surface and the field is uniform. So because it's a flat surface and the field is uniform, we don't have to worry about integration or anything. I can just say that the phi value, the value of electric flux for this surface is simply E vector dot S vector. That's it, right? Okay, so here I'm going to take the S vector normal to this plane in this direction, right? So this is going to be the S vector. So I can also obviously write it as ES cos 0 in this case because S vector is towards the right hand side and E vector is also towards the right hand side. So this will give you E's value is 3 into 10 raised to 3, okay. S, that is magnitude of this surface area vector or area vector, so 100 centimeter square, so that is 100 into 10 raised to minus 4, alright, and cos 0 is obviously 1, so this will give us 3 into 10 raised to 3 minus 4 minus 1 and plus 1, 3 into 10 raised to 1, and unit of flux is Newton meter square per coulomb, alright, and flux is a scalar, so we don't have to worry about direction, okay, or you could just write 30 into 30 Newton meter square per coulomb. Okay, so this is the electric flux linked with this surface or associated with that surface. You might have a question, is it not possible to put the area vector in this direction? Is it valid? Yes, it is, right? It is perfectly valid, right? Because if it's a surface open, just a single surface, then it's not possible that there is only one perpendicular, right? You could have perpendicular this way, you could also have perpendicular the other way, right? So what this means is that there are two possible answers. So the other possible answer is going to be, if you take this angle to be 180 degrees, I don't think you'd have a problem with that, right? But keep in mind that for such surfaces, single open surfaces, you can have two possible answers, right? Okay, I am not going to repeat the calculation. I'm sure you know what it means, right? So this is it about the part A. Now part B. Okay. Now part B says, what is the flux through the same square? So we are still having the same square. If the normal to the plane makes an angle 60 degree with the x axis. Well, so we are given once again that what we have here is the uniform electric field in the same manner, okay, going towards the x axis, positive x, right? But now the square is not parallel to the YZ plane, rather the square is such that the normal to the square, so let's say this is the normal to the square, it is making an angle 60 degree. So the square would actually be looking like something like this, right? So the square has now been tilted, and now the normal to the square, or the area vector of the square, is making an angle 60 degree with the uniform electric field. So in this case, I'm sure you do realize that again, if you want to find out the electric flux, because it's plane surface and it's uniform field, we just have to use this formula, right? So this time theta's value is not 0, right? It's 60 instead. So this is going to be cos 60 degrees. E is 3 into 10 raised to 3, and surface area is 10 raised to minus 2, right? 110 raised to minus 4. So finally, you get 30 by 2, right? That is 15 Newton meter square per coulomb. Alright, so that's what we have for the part B. Again, the only difference between part A and B is that the square has been tilted, so obviously the flux would change, right? Again, this justifies our basic idea about vectorella. I hope you remember that if rainfall is occurring on a flat surface, if you tilt that surface, then the amount of water falling on that would change, right? So that exactly happened over here. All right, so that's it for this problem.